Okay, guys, this is if you need a little review before the final exam today or tomorrow. I'm going to go over the right column of all our exponent properties. So if you need to watch this before bed, first hour, second hour, third hour seminar, here we go. So you will be testing in fifth hour today. All right, so we're going to test some of these exponent properties here. So this first one here, remember our leading coefficients, there's a multiplication sign. So these two numbers are going to get multiplied. 2 times 3 is 6. And when multiplying like bases, you add the exponents. So this u has a 1, this v has a 1. So I'm going to put them in alphabetical order. My u has a total of 1 here and 3 there. Add them together, you get 4. And on the v, that is the only v, so it is just v to the 1, or you can leave that 1 off. That is the answer. Number 4, we have an exponent outside the parentheses, and that property called for us to do some distributive property or multiplication. The 4 has a 1, the n has a 1. So that 4 gets distributed into each exponent one time, so that we have a 4 as our first base. 1 times 4, and then our next base is n. 1 times 4 is 4. And that simplified in the calculator is 4, this button right here, to the 4th power is 256. So that equals 256 n to the 4th. Okay, moving on. Now we have division, a fraction bar. That means we're going to subtract like term exponents. So first you have to take care of those coefficients, and there's an invisible 1 out here. So 1 over 4 is just going to become 1/4. And then we can decide what happens to all the other bases after this. I'm going to move negative exponents. So this one goes to the bottom. This x is going to go to the top. So we already have x3 on the top. Now this one, x3, is getting moved to the top. And you can cross off as you go so you don't double up or forget them. We took care of the 1, took care of the x3, took care of that x3. Now this y to the negative, this 4 is already on the bottom. y3 will stay on the bottom because it's positive. It's not going to move. Then we have this y to the negative 4 coming down, and it becomes positive. Now I just need to combine. So that's 1/4. Total of 6 x's on top and 7 y's on the bottom. And nothing can be simplified farther. Number 8, 3 over 2. That cannot be simplified. Remember, if you're not sure, type that in as a fraction. 3 over 2. Just hit enter, and notice it did not change. It's still 3 over 2. Y. That's the only y, but we have 4 x's on the top and 1 on the bottom. When dividing, we subtract. 4 minus 1 is 3, and the bigger number is on the top. That is where that number will stay. That looks kind of bad. 3 halves y x3. Something like that. It might also look like this, just in case you were wondering. x3. They might be off to the side. All right, number 10. Here we are multiplying again, just as we did up in number 2. So I'm going to multiply the coefficients. There's an invisible 1, 4 times 1, and then the r, and we add the exponents. So 5/4 and 1/2. 5 over 4 plus 1 over 2, and we get a 7 over 4. So that is the exponent for the r, and that is the final answer. Number 12, we have an exponent on the outside again, just as we did up here, except now we just have fractions. Do it the same way. So we have a k, That exponent is the 1/2. So 1/2 times 2. And if you did that in the calculator, 2 times 1/2, you get 1. So it could just be k to the 1 or k. Either one works for that. Okay, this question I got a lot while students were working on this one. It's not that difficult. Looks like a word problem. It's just asking if the fifth root of 10 is written with an exponent, what would the value of x be as a simplified fraction? So all they're wanting you to do is rewrite it from radical form to exponent form. So the 10 is the base, and then what do we want as our fraction exponent? So remember the number out here, which is an invisible 1, goes on the top, and then that index, that root, is your denominator. So it is just 10 to the 1/5. So x is that 1/5. That's all that means. And that is simplified. So if this were 4/8, we'd want to simplify it to 1/2. All right, this one is stating write each expression in radical form. So I'm not simplifying this, I'm just putting it into radical form. That is the base. So I'm going to keep it as the base. Now we just have to move that 5 and 2 just as up here. So that index is the denominator. The denominator is the index, and the 5 would go out there. So you don't need that 2 there. It is already a square root. So it could look like this also. You don't need to write that 2. Okay, flipping over. 18. Now we're rewriting in exponential form. So the opposite of what we just did. So 5k is our base, and there's an invisible 2. Oh, kind of blurry there. There's an invisible 2 there. So that is the number on top, and that invisible 2 would be the denominator. And that's it. Down here, the n is our base. And I probably wouldn't have needed the parentheses here. The 3 is going to go on top. And again, there's an invisible 2 there. N to the 3/2 power. To do one with a number over there, let's try number 19 also. 10n is the base, 7/4. Remember, if there's no number here, it is a 1. Okay, it's a little blurry again here. It'll clear up. Number 23, now we're just simplifying on the way down. And 150, remember we want to use those perfect squares, and those are 1. 2 squared is 4, 3 squared is 9, 4 squared 16, 25, 36, 49, 64, 81, 100. So that's 1 squared, 2 squared, 3 squared, 4, 5, 6, 7, 8, 9, 10. So those are handy to know. I don't think we'll need anything bigger than that down here. I know in the homework we did. 150. 100 is not going to go into it. And remember, you can just divide by each of these to see which one does work. I know 25 will work there. But again, just remember to test it. 150 divided by 81. You're going to get a decimal. So then you move on to the next one until you get a whole number. And 150 divided by 25 is 6. So this is the same thing as the square root of 25 times 6. And the reason we do this, because that is a perfect square, and it is 5. We do not take the square root of 6, so that stays under that radical, in that radical. All right, this one has a number on the outside, and there's one like this on the test. So 180. We want to find a number that goes into 180. 180 divided by 81, 180 divided by 64, 180 divided by 49, 180 divided by 36. There we go. 36 times 5. 36 times 5 is 180. And don't forget that 4 out there. That's important coming up. Square root of 36 is 6. So that 4 is on the outside. It'll get multiplied by the number we bring out, and the 5 stays inside. And now you want to multiply those two numbers. 4 times 6 is 24. Square root of 5 is the final answer. Then on our last lesson, we started throwing the letters, the variables, into the square roots. So 48, we still want to approach by finding a number that goes into it. I'm going to start with, I know 25 doesn't go into it, that goes into 50. 48 divided by 16. There we go, 16 and 3. 48 is 16 times 3. Now the variables. There's a couple ways you can do this. The way I taught it in class was we divide the number by 2. You want to make an even number, and that is even, so we can leave that alone. So that is R4. It's just like another thing multiplied. So the square root of 16 is 4. The square root of R4, that's an even number, so we just divide the exponent by 2. 4 divided by 2 is 2. So it's perfect square. The thing we did not use is that 3. That is the final answer. So we did several of these, so hopefully you're getting used to them. 196, a bigger number. 100 does not go into it. Let's try some of these others. 196 divided by 81. 196. Actually, I'm going to first see if it is a perfect square. Square root of 196. It is. So 14. So we did not go up to 14 here, but it's always good to check if it is a perfect square. And 196 is. So 14 is going to come outside. I'm going to leave that then 196. X cubed, that's an odd number. So remember, you'd subtract 1 and just put that extra 1 next to it. Then we have y4, which is even, so that one is fine. So the square root of 196, 14. Square root of x squared divided by 2. 2 divided by 2 is 1. That's odd. This is even. 4 divided by 2 is 2. So what did we not use? That single x. So it should look like that. All right, 31. State if each expression is equal to 3 or not. And there's a question like this on the test. These you literally just plug into the calculator. So if you know how to operate the square root symbol and the fraction and the exponent symbol, you should be fine. So let's do all 4 of these. Cube root of 27. That is under math. It's kind of blurry. And the cube root symbol is number 4. You just hit 4. Cube root 27. You hit enter. Well, it does equal 3. So you would say yes. Next one. Square root of 3 squared. So I'm going to use that symbol. Square root of 3, and that's underneath. So I'm going to use the square button or the exponent button. Just make sure it matches what's on the paper or in Mastery Connect. It is 3. So that also equals 3. So 2 for 2. 2 to go. And just type it in exactly as it looks. So we start with the parentheses, then we have a 3, exponent 4, closing it up, and then an exponent, and then a fraction. 1 over 3. That does not equal 3. That equals 4.326748711. So no. Last but not least, 27 to an exponent and a fraction. 1 over 3, and that also equals 3. The other way you can do it is 27 exponent, and you could do 1 divided by 3 like that. Means the same thing. There you have it. That's a rundown of everything you will see on this final exam. Good luck.